Hello class, this video is for chapter 1.5 of our book, and we will be discussing integrating factors. Now this is a tool that we use to solve a class of differential equations that have this form: dy dx plus px times y equals qx, where px and qx are continuous functions. So more or less look out for when we have a y prime and a y in the same differential equation and see if it fits this form. Now the way to solve this is a little tricky. You have to do something that is a little unintuitive. The first thing you do when we handle this equation is to multiply both sides by this exponential term. And this exponential term is e integral of px dx. What we end up with is this. Right, that didn't seem to make the problem any easier, but there is a method to our madness here. So let's just carve out a little square and to show you something. So the point is that we want to use the product rule here, and we observe that this expression on the left hand side now looks a little bit like something that the product rule would produce. Here's what I mean. Now consider this expression. So we differentiate y e px dx and what we get is dy dx times this plus y times the derivative of epx dx, and this is just going to be e antiderivative of px plus y. So recall what happens when we differentiate an exponential. The term stays and we differentiate the exponent. So this becomes times d integral of px dx times the original expression. And of course, we are taking the derivative of an antiderivative, and this just becomes px which is exactly the expression we have here. Alright? So the point is that this is actually dy integral px dx equals qx e px dx. Now writing the expression in this form allows us to take the antiderivative of both sides. So remember that the antiderivative of a derivative is just the function itself. So we have y e px dx equals qx e antiderivative of px dx. Okay, so we took the antiderivative of both sides in this step. And now, oh right, plus c, of course. And now we have our expression for y. Y is going to be equal to e x qx e antiderivative plus c e minus antiderivative of px dx. Now this is going to be our general solution. And of course, if we have an initial value problem or have some other information, we can solve for c. Alright, so this was a bit of a doozy, and I'm sure this step seemed like it came out of the blue. I think the better way to handle this problem is not to memorize this formula over here, as you are tempted to do, but rather to think in terms of the product rule in differentiation. And hopefully a few more examples will make it clear what I mean when I say think about the product rule.